Okay, for this one, we're going to start off the same way we did on the previous one. We're going to write the equations down and we're going to number them. Now, the difference between these ones and the previous question is that these do not have one of the variables as the subject. The other ones had y equals such and such, y equals such and such. And so we were able to just substitute in because they both equaled y. Now, you could rearrange these so that they both equaled x or both equaled y, but they're messy numbers. They're not nice, neat numbers. So what we're going to do is we're going to use what we call elimination. And it's not that difficult a method once you get the hang of it. But it does take a bit of paying attention to what's going on so that you can get it. So we're going to write them down. We're going to label them number 1 and number 2. Equation 1 and equation 2. Now what we're going to do is, because they are messy, what we're going to do is we are actually going to manipulate those equations. Remember what I said about the fat man, thin man? Okay? As long as you do the same to both of them, they will stay equal. Okay? So it doesn't matter what we do to these as long as we do it to both sides. So what we're going to do is the whole thing, elimination. Do you guys know what elimination means? In its most basic form. If you eliminate something, what have you done? Get rid of it. So that's what we're going to do. That's the whole purpose of this. So what we are going to do is we want to make it so that you can use one of the equations to get rid of one of the variables, either the x or the y. Because what we want to end up with is y equals something or x equals something, so that we can then substitute it back in to find the other value. Okay? So in the end, it's very similar to the previous example, but we're not using substitution. So what we're going to do is I'm actually going to take this one. I'm going to take number 1 and I'm going to times it by -2. Okay, the whole equation, everything in the equation. Okay, the reason why is because that is 2x. Okay, so when I times x by -2, what am I going to have, Kirby? X times -2. Yes, you do. X times -2. -2x. Okay? And this will make more sense in a second. Then I'm going to do -5y times -2. So 2 minuses will make a positive, and what's 2 times 5? So it's 10y. Then I've got -17 times -2. Which part are you confused with? Okay, because we're doing -2 times -5y. Why we're what, sorry? Timesing everything. All of equation 1 times -2. Okay, so we've now got -17 times -2. 2 negatives give you a positive. What's 2 times 17? Okay, and we're going to call that equation 3. So we've now changed equation 1. Equation 1 is now gone. We've now got equation 3. How does that help us? How does that help us? We want to use elimination. Can you now have a look at equation 2 and equation 3 and see how we can use 1 to eliminate one of the variables? Yes, except one's a negative, one's a positive. So now, if I actually take, okay, equation 2, and I'm going to add it to equation 3. So I'm going to take everything in equation 2 and add it to everything in equation 3. Cool? So I've got equation 2 is 2x plus 3y, and then I'm going to add the stuff from equation 3. So minus 2x plus 10y. Cool? That's the left-hand side. Okay? Everything from equation 2, everything from equation 3. Happy with that? Then I've still got the equals, and I've got equation 2 is 5, and I'm going to add 34. So I've added everything on the right side. Happy with that? So I've just added those two equations. You'll notice I'm writing exactly what I'm doing there. Now we use our collecting like terms. So we've got 2x minus 2x. What does that give us? 2 apples minus 2 apples? No apples. So they cancel each other out, which is awesome. Which leaves us with 3y plus 10y gives us what? 13y equals 5 plus 34? 39. Pausing, hang on. No, two positives make a positive still. If you've got two of the same, it's all like two negatives or two positives. No, it's only when they're different that it's a negative. You can be really racist about it and say, if they're the same, it's okay. If they're different, it's bad. Isn't that what we say? Racist little muppet. Poor Levi. Okay, so we're left with 13y equals 39. Now we can work out what y equals. How do we work out what y equals? Excellent. Divide both sides by 13. And we'll end up with y equals what? Well done. So we've now got a y value. So can you see what we've done and why we've done it? Okay, we manipulated one of the equations so we could eliminate one of the variables so that we could find out what the second variable's value was. We've now got y equals 3. So now what do? We've got the y value. So if I was writing the coordinates in, I've got something comma 3. So that's part of our point of intersection. What do we have to do now? Find the other part. How do we find the x part? Tegan, you should know this off the top of your head. Well done. We substitute that 3 back into one of the equations. Okay? Any particular equation you want to substitute it into? I'd substitute it into the top one because then you got x by itself. You don't have to do anything to x. Cool? So what we'll do is we'll go sub into 1. Okay, so I'm writing down exactly what I'm doing. So I've got x minus 5 times 3 equals 5. Happy with that? Where there was a y, I've substituted in the 3. Did I write the right equation? Yes. Because I'm substituting into equation number 1. Because it's minus 17. See, I knew I'd written something down wrong. Thank you, Jacinta. Minus 17. Thank you. So we've got x minus 15 equals minus 17. Then what do? Come on, what do? X minus 15. You certainly do. We're back to doing that stuff that we've done a few times. And we end up with x equals what? Minus 2. Awesome. And we've now got our point of intersection. Does that seem all right? It is a bit more complicated because you have to manipulate the equations. Okay? But the thing to remember is when you manipulate equations, as long as you do it to both sides of the equation, you're pretty much fine. Okay?